Good morning and welcome. Today we are going to have a very quick little bootcamp to create an NFT smart contract inside of or with Solidity. A Solidity smart contract will be right for all EVM compatible blockchains such as obviously Ethereum, Polygon, Avalanche, and a few more. So let's start by opening the terminal, waiting for it to actually open. Because we're going to use HardHat, we need to initialize npm with the -y parameter. It will automatically just save all the default settings. Then we say npm install save dev HardHat. This might take a while, I'm not sure. After HardHat has been installed, we need to use the npx keywords inside of the command line to run all the HardHat things. Yeah, this is going to take a while, so let me just pause the recording. Alright, now that HardHat has been installed, we can also install OpenZeppelin, since we're going to use OpenZeppelin for a lot of ease of work /contracts. OpenZeppelin, if you don't know, is a company that has a lot of open source, standardized smart contracts ready for you to just copy and paste and implement. For example, the ERC-721, so the standard for NFTs, already has all these functions that you do not have to implement yourself, together with some events that will be triggered. For example, when you transfer an item, they will also be triggered when you mint an item. You have the save mint, which you can override to accept any sort of payment or set certain limits. It also has a lot of extensions, such as URI storage, which will mean that you have more flexibility over the token URIs, which will contain the metadata of your tokens, for example, the name, the description, the image, and all the other things, which marketplaces like OpenSea gain or get from the token URI function that's right here, which we do not have to override, at least not by default. If you want, you can set a setter for the token URI, or you can implement the base URI functionality. Okay, so OpenZeppelin's contracts are installed by using npm. You can see it right here under @OpenZeppelin. Then we have all the smart contracts that they have. We will only use ERC-721. Okay. So when that is done, we need to do some more for HardHat, which is npx HardHat. It will then prompt us for which kind of project we want. We want an empty HardHat config file, which is this right here. Right here, it only has the compiler version that we want, and this is fine. We can now add a folder called contracts, in which we can create our my token.solidity. In here, we can already specify a Solidity version and a license. The license is just for now, just to reduce the amount of warnings we get, because otherwise it will give a warning. And the Solidity version we can simply match to whatever is inside of our config, which is also easier. Or let's yeah, let's see what OpenSea uses, or OpenZeppelin, I'm sorry. That way we can have all our smart contracts on about the same version. Okay, they use 0.8. So let's do it like that. And add it to our config file as well. Like so. Don't forget to save the file, obviously. Alright, so let's create our smart contract. Our contract, my token, is ERC721. But of course, for that to work, we need to import the smart contract. You can find this import line of code right here. Or you can just check what the path is from inside node modules. So it's at OpenZeppelin. So it automatically goes into /contracts since that's the only one we have installed. Then it goes to token ERC721 and then it gets ERC721.sol. If you only want to implement the interface, you can use ERC721. And you can also get the extensions from here. Alright. So let's create some brackets. Let's see what it wants. It should be marked as abstract. I'm not sure if that is necessary. So you can say constructor. I think it's like this, ERC721. It wants a token name and a token identifier. So let's see, this should compile. So we say HardHat or npx HardHat compile. It won't then try to compile it. We could get some errors like, we get some errors from the Solidity versions. It cannot be compiled since it doesn't, some files don't match the version that we have selected ourselves. So right here, we do have selected this one. So to add the functionality that we can compile multiple versions, which we should probably do for all these errors, we just need to alter what is written right here. So instead of just having Solidity and a version, we need to say compilers, which is an array of objects which contain each version that we want to compile, which is this one. And also 0.8.1. So 0.8.1. Let's see if there are any others. No, it looks like this is it. And then optionally you could have settings, but as you can see, it's not necessary. So let's see if it will compile right now. This is something that you would always have to do for creating smart contracts whenever you use newer or other versions. Let's see. It could be that it should be read like this. It's always a bit of a search, but as you can see, our files have been compiled successfully right now. And even though we only have one file that we created ourselves, 10 Solidity files were successfully compiled. That's because, let's see if I can open this. As you can see, the ERC721 smart contract implements quite a few other contracts. And some of these might also use other smart contracts as well, which is why it compiles 10 files instead of just our single one. Okay, so essentially we are now done. But almost every smart contract has some extra functionality, like you probably want to get paid for minting tokens. To do that, we would have to override a function, the SafeMint function, or we don't really have to override the SafeMint function, but we need to call it from within another function. So we have to and token ID. All right, to get the token ID, we can just have a private counter. Like so. Well, let's say it starts at 0. Then we want to create a function from which we can mint. So let's call it mint. We don't have to override anything, but we do need to have a function that we can call. It would be an external function. It won't return anything. Since it will use an outside variable, it won't be a pure function, and since it will alter data, it will also not be a view function. So the function would be something like this. Then within this we can call SafeMint, which wants to, which would be the message.sender in almost every case. And we will set the token ID as the counter. And then we don't want to forget to update the counter. So let's make it nice and syntactic correct. So we now have this, but we still don't get any payment. So how do we do that? We make this an external payable function. This will mean that we have access to the message.value variable, which we can create a require statement for. So we can say message.value should be more than or equal to. I always use more than or equal to. Let's do something outrageous, but just for testing purposes, we can say 1 ether. And otherwise, it will revert the transaction saying we have not gotten enough ether. All right. Let's compile this. And let's see how many errors I've created. 0 errors. And you can notice now it has only compiled 1 file. That's because all the other files have not been changed, so they don't need to be compiled again. Which is of course pretty logical. So this is it. This was the quick bootcamp for creating an NFT smart contract. There's loads more functionality that you could add, but this is the only thing that you need to add. If you want to learn more, I highly suggest going to the OpenZeppelin webpage and just checking out all of the functions, or at least all the important functions such as balance of, the owner of, the transfer functions, and how to add a token URI, because that's pretty important as well. But essentially, for a simple smart contract for NFTs, this is it. Thanks for watching. Have a nice day.